welcome back to Math Concepts. In this video we're going to talk about several statements that are related to the conditional statement, not necessarily logically equivalent to the conditional statement, but related to the conditional statement. So they're fairly important constructions. They do come up a lot, and sometimes people make mistakes and switch one for the other when they're really not the same. So it's important to understand these different varieties. So let's go to the document camera and look at some examples. So after watching this video, you should be able to take a conditional statement and write the converse, inverse, and contrapositive of that conditional statement. Okay, so the standard conditional statement has this form: if P then Q. Okay, remember that's the symbol for a conditional or an implication, so if P then Q. The converse is if Q then P. All right, so if we take a conditional statement for a specific example, let's say if it is Saturday, then it's the weekend. That's a true statement. If we look at the converse would say if it's the weekend, then it's Saturday. And notice that is a false statement. Okay, if it's the weekend, you have two options. It could be Saturday, it could be Sunday. So if it's the weekend, you cannot necessarily say it's Saturday. So the conditional and the converse are not equivalent, as you can see in this little diagram. The converse, however, is equivalent to the inverse of the conditional statement, which is not P implies not Q. If it's not Saturday, then it's not the weekend. But notice that is not equivalent to the original conditional statement. Now the contrapositive says not P implies not Q. So in our example it would be if it is not the weekend, then it is not Saturday. And you can see that is equivalent to the original conditional statement. Okay, so a couple of important forms, and they are related in pairs. The converse and the inverse are logically equivalent, and we'll see that with truth tables in just a sec. The conditional and the contrapositive are related. Okay. So a specific example here. We're going to take a conditional statement. If we have a quiz today, then we won't have a quiz tomorrow. We're going to write the converse. If we won't have a quiz tomorrow, then we will have a quiz today. Okay, so you can see with a converse you just switch the two parts. In the first conditional we have the antecedent, we have a quiz today, and we have the consequent, we won't have a quiz tomorrow. In the converse we switch them up. We won't have a quiz tomorrow comes first, we will have a quiz today is the second part. Okay, inverse. We got to negate both of them and keep them where they are in the original statement. If we have a quiz today, then we will have a quiz tomorrow. Okay, notice my original conditional statement. Oops, gotta fix that, made a mistake. It should have been If we don't have a quiz today, then we will have a quiz tomorrow. Okay, notice in the second part, it says we won't, and of course if I negate that, that means we will. Okay, so that's the inverse. And finally, the contrapositive. We have to negate both of them and switch the order. Okay, so I'm negating this, I'm putting it first. If we have a quiz today, if we have a quiz tomorrow, then we don't have a quiz today. Okay, so that is the contrapositive of our original conditional statement. Okay, so just remember the parts. With the converse, you switch them. With the inverse, you keep them in the same place, but you negate both of them. With the contrapositive, you negate and you switch. Okay, let's look at some truth tables here. Okay, we know the truth table for the standard conditional. Okay, remember the standard conditional is true in all cases except when the antecedent is true and the consequent is false. Okay, so we kind of think of this arrow as an operator. If this part is true and this part is false, then it gives you a false. Otherwise, it gives you a true. So we're going to apply that logic here. Let me copy down the values for Q here and the values for P here. All right, and then we're going to apply this arrow operator. Now remember, the only time we get a false is when the antecedent is true but the consequent is false. Every other time it's a true. Okay, so this is the truth table for the converse. Okay, note that the values are different. That shows that the converse and the original conditional are not equivalent statements. Okay, let's look at the inverse. So I have to negate P. So whatever truth value P has, I put the opposite. And here I've got the negation of Q. So remember, we're looking for this here. Whenever the antecedent is true but the consequent is false, this gives you a false. Otherwise, it gives you a true. Okay, so this is the truth table for the inverse. And notice that we have the same truth table. And that tells us these are logically equivalent. Lastly, let's do the contrapositive. I'm going to put the negation of Q over here. And over here I'm going to put the negation of P. I'm going to look for the one place where the antecedent is true but the consequent is false. Okay, there's the truth table for the contrapositive. And notice it's the same as the truth table for the original conditional statement, showing that these two are logically equivalent. Okay, so be ready for questions that give you a conditional statement and ask you to write the converse, the inverse, and the contrapositive. And also realize that the converse and the inverse are distinct from the conditional, while the contrapositive is logically equivalent to the conditional.